Okay, here we go, class. So today, we're going to piggyback off of what we did or what we were on yesterday, okay? And it's a continuation of what we have been doing all for since last week, okay? We were creating models to represent the strategy of multiplying fractions, okay? So our learning target for today is I'm learning to use visual models to represent the multiplication of fractions. You are successful, which is your success criteria. I can use visuals and diagrams to successfully represent the multiplication table, the multiplication of fractions. All right, so our opening for today is a notice and wonder. Okay, you're going to take a look at this picture or take a look at these images. Okay, you should not be moving while I am talking. Okay, you should be looking at these images, these two images. It says same but different. Same but different. Look at the images below. What is the same about both images and what is different about both images? Okay? There are two questions while you're looking at the images that you should be asking yourself, and what I am going to ask you. How would you describe image A and how would you describe image B? Okay? I'm going to give you 3 minutes or less to look at these images, and I'm going to randomly call on you. Okay? So, here we go. I'm going to blow it up just a little bit bigger to make sure that you can get the full effect of what each picture looks like. Okay? We're talking about fractions. We've talked about unit fractions. We've talked about the product. Take a look at those and tell me what looks alike and what looks different about those images. When I call on you, be very detailed. Okay? Look at those images. You should be able to recognize what type of shapes they are. You should be recognizing what is going on in the colors in the picture. You should think back to also what we have been doing in class as far as fractions. Okay? I'm going to call on a boy first. Marlon, what do you notice or what is the same about both of those pictures? What is the same about both of those images?
I noticed that A and B had at least one half shade or more.
Okay. You notice that about one picture, but what is the same about both of the pictures? Everybody need to sit up. What is the same? When we talk about something that is the same, boys and girls, we talking about things that look what? Alike. Okay, and when we talk about something that is different, that means that each one of them have a unique feature. Just like all of us, we all do not look alike. Okay? So what is something that is the same about both of those pictures? Or both of those models? Okay? Mr. Vons. They have the same shape. Okay? Are we talking about the outside or we're talking about on the inside? Okay? And what shape is that? Okay? And what is different about them?
One of them has only 2 parts.
Okay?
The other one has 4.
Okay? He said, which one has the 2 parts? Part A has 2 parts, and how many parts does part B have? 4 parts, okay? Very good, all right? So, Miss Hammond, describe image A in your own words. How would you describe image A?
I would describe it as like a fraction, which is a half, because 1/2 is shaded of the whole square.
1/2 is shaded of the whole square, okay? What will be your numerator?
My numerator would be
Okay, and what will be your denominator? 2, okay? So this represents that 1/2, there are 2 parts. 2 parts represent the denominator, and with 1 part being shaded, that represents 1. So altogether, to make a fraction or create a fraction to represent this model, it will be a half, all right? B, Miss Williams, describe image B. Okay, 3 parts of it is shaded, but 1 is not. Okay, who could give me a little bit more detail on what's going on with those 3 colors? Come on, Mr. Leonard Parks, Mr. Parks.
One side, only one square is shaded twice.
1 square is shaded twice, and what square would that be? I'm gonna say this is 1, 2, 3, 4. Which one is shaded twice?
3.
Number 3. Raise your hand if you agree. Okay? Okay? Miss Davis, I need you to create a fraction that would represent image B. 3/4. Okay? The 3 represents what?
how many is shaded in,
How many that is shaded in, and what does the 4 represent?
how many groups,
How many groups or how many? Who want to help her out? Come on, Miss Martin.
How many squares in all?
How many squares in all? How many squares total? Okay, here we go. So boys and girls, that's what we're on today. We're going to talk about area. Same thing on what we did on yesterday, but today you're going to work in groups. All right. Once you get your sheet, you're going to have take one past it. Okay, you already set up in groups. If you don't have that many people in your group, I am going to pass one over. I am going to put some people in your group. Okay, take a look at what I give you. Okay, it says multiplying fractions. All right, we're looking at patterns on today. Anybody did not get a paper. Okay, so right now I'm going to start moving some people. Okay, Miss Lannis, you will move to this group. You guys are already one group. Hosey, you will move to this group right here. Ivy, you will move. Come on, let's start moving. You should start moving now. Miss Ivy, you are going to move to the first group. Miss Martin, you're going to move to the group over here. Marlon, you're going to move to the group, Miss Davis group. And Chance, you're gonna move to that. Chase, you're gonna move to that group. Okay, let's talk about it. Let's look at we're talking about multiplying fractions. Multiplying fractions. Okay, where it says patterns. So we're really looking for patterns as we complete today's assignment. Okay. Okay? You should be looking at, oh, no. You should be looking at your paper as I'm looking up here on the board. I'm reading exactly what you have on your paper. So the first part says, explain or show how each expression can represent the area of the shaded region square units. Be prepared to share your thinking. Okay, this is the first part. You and your group are going to look at A, B, and C. Okay, you're looking at this model. Explain or show how each expression. Okay, A says 8 over 30, 8/30. Okay, B actually gives you an expression. 2 times 4 times, and in parentheses, 1/5 times 1/6. And C says 2/6 times 4/5. All right? Explain. I want you guys to talk about, and I'm going to call on 3 groups. How many groups we have? We have 4 groups. Okay? I'm going to give 2 groups B. Sit up, Mr. Tanksley. I'm going to give 2 groups B. Okay? This group right here is going to take B, and this group back here is going to take B. You guys are going to take A, and you're going to take C. Okay? All right? So here we go. You're looking at this. We're going to take about 5 minutes. And you're going to be able, talking amongst your group, you guys should be able to explain or show how each expression can represent the area of the shaded region square units. All right? Look at your model. Think back to what we have been doing. All right? On B, you guys have an expression. You have an equation. Think back to, please excuse my dear Aunt Sally. What is that called? PEMDAS. But what does PEMDAS represent? Okay. First we do is in parentheses. Second we do what, if we have exponents, then what's next? We do multiplication and division, whichever one comes first, and then next we do what? Addition and subtraction. That is called order of operations. So you go ahead and start now. Okay, you got 5 minutes. You should be explaining or show how each expression can represent the area of the shaded region. I will call on you to explain somebody in your group. Pick who is going to be the spokesperson. Okay, you start. You should have been wrote your name and today's date. Okay. Everybody needs to give some input. We're talking about first, you guys stated, slide your chair up, put your back to the chair for me. First, you guys stated, okay, we talked about, asked you what does please excuse my dear Aunt Sally was, and you said that was PEMDAS. Okay, so look at what you have. Do you have anything in parentheses first?
Yes.
Okay, so you must solve what's in parentheses. So that dot there, that's another symbol for multiplication. Good job. Okay, so you need to solve what's in parentheses first.
Cause these the whole numbers, and you multiplying the whole number from a fraction, so the whole number gonna be the numerator, and the one gonna be the denominator. So you
So say that
multiply
one more
them
time.
2 times. Well, first we did 1/5 times 1/6 will be 1/30, and then you gotta do 2 times 4, which is 8, and then you gotta multiply them two. But 8 a whole. a whole number can't go into a fraction, so you gotta make that whole number into a fraction.
Okay, are y'all writing all that down though? Y'all saying a lot, but are we writing it down?
They're both even numbers, but
So we
they
can't
can't
figure out 8 over 30 because 8 can be even.
it says we can show
Okay. All right. So then, you need to explain how does this expression represents this model? Who can explain it? You guys need to be able to explain it in your own words. How does that expression or equation represents this model?
And since it's both even, you can simplify.
Did the directions say anything about simplify? Okay, everybody should be giving input. Nobody should just be sitting here writing down answers. Everybody should be giving some type of input. What have you contribute?
So me, Zamir, and Cookie, and them, we talked about writing a model, and then we was gonna write the model, but she wanted but we was gonna simplify it, but then you came and said that didn't say anything about simplifying.
Well, correct. So right now it doesn't tell us to simplify. Okay, so what did you have? You had 2/6 times 4/5. So basically the strategy y'all use, what was the strategy y'all used first to solve the problem?
We did 2 times 4
and then
8 and then 6 times 5
equals 30.
Okay, and the 2 and the 4 represents the what? How many was shaded? Okay, and the 6 and the 5 represents what?
Wasn't all like the denominator.
The denominator, okay. Okay. All right, I'm gonna go to the next group. Boys and girls, you got less than 50 something seconds.
First, you gotta do
So with y'all problem, did y'all have to do any work? They gave you 8 over 30. So did you have to do any work? No.
We looked at the model and we could tell that it's like 30 because it's 5 by 5 and
Okay, 5 times 5.
6 by 5.
6 by 5,
And
okay.
it's 30 and it's 8 shaded, so it's 30 in all. And this is our denominator and it's 8
Okay.
shaded.
All right. Who's going to be able to talk about that in front of your peers? Okay, y'all pick the spokesperson. Remember, you have to have a spokesperson for your group who's going to be able to explain. Okay. All right. All right, boys and girls. Everybody should be looking up at me. Time is up. Okay. So let's talk about the first one first. Let's talk about the first. Let's talk about on the A, they gave you 8:30. Who was group A? Okay, and who's your spokesperson? Okay, let's go ahead. Please explain to your peers how that expression 8/30 represent the model.
Okay, I said 8/30 represents the model by showing how there are 8 out of 30 parts shaded.
8 out of 30 parts shaded. Okay. All right. Do you guys agree?
Yes.
Looking at the model. Okay. So, we have, if you count each part, there should be a total of what? 30 represents the total number of parts. 8, which is the what? What is 8 called? The numerator. The numerator is 8 because it represents what's been what? Shaded. Okay. Come on, group. For number B, I had 2 groups working on that. And I want to hear from both groups. Who your spokesperson? Okay, Miss Davis. Go ahead and explain to them every step you guys took, and then, yeah, every step y'all took, and then how does it represent the shaded area?
Okay. So what we did is we multiplied the fractions first, and that gave us 1/3. Then we multiplied the whole numbers, and that gave us 8. Then we did 8 times 1/3, and we put a 1 under the 8 because you can't multiply a whole number times a fraction, and that gave us 8/3, and that represents the area of it because we have 30 unit squares, and then 8 of them shaded.
Okay, boys and girls, raise your hand if you've seen a problem like B before. Okay, you've seen a problem like B before. Okay, there was 2 steps that y'all did not state. And let's see if this team over here, who's your sports your talking person, your spokesmodel, Miss Sandra.
Okay, so we multiplied 2 times 4, which gave us 8.
Okay, so boys and girls, I'm gonna stop right there because I heard both groups say the same thing. Okay, I asked y'all the question about what does please excuse my dear Aunt Sally mean? We said it was penmanship and its order operations. So you guys are saying first you multiplied 2 times 4. But is that the correct way to solve that? No. The first thing you guys were supposed to do was in parentheses. And what's in parentheses?
1/8 times 1/6.
1/5 times 1/6. So I want you to start from there.
Okay.
Okay? How about you get a marker and go demonstrate on the board?
Okay.
Can you see the problem, or you need to take your paper?
I can see the problem.
Okay.
Okay.
Okay, first sheet is multiplying 1/5 times 1/6. Okay? The first thing we do when multiplying fractions, we do what? We multiply the what? Numerators. So what's 1 times 1? 1. Okay?
Yeah.
Now we multiply the denominators. Was 5 times 6? 30. 30. Okay? So now we still have a 2 and we have 4. She's going to go ahead and do 2 times 4. 2 times 4 is what? 8. Okay? Now we have 8 times 1/30. How can we multiply 8 times 1/30, or does it something need to happen? You tell them.
Okay, so I think we should multiply 8 times the 1 over the 30, which would give us 8 over 30.
Okay? Boys and girls, what happened? What happened?
She forgot to put a 1 under the.
Okay? You forgot to turn. You have to first turn this whole number. 8 is a whole number. You got to turn it into a fraction. So how do I turn it into a fraction?
You put the 1 under the 8 as the denominator.
Okay? Put 1 under the 8 as the denominator. Now we can multiply what? 8 times 1 is what? 8. And 1 times 30 is 30. Okay? Now, how does this represent the model? How does 8/30 represent the model? We've said it one time before, but I want to hear it in your words, your group words. Your group.
Okay, so it is
Come on,
It
Kurt.
has a length of 6 and a width of 5. So you,
Okay, you talking about the area.
yeah.
Okay. So with area, what's the formula for area?
Length times width.
Okay. For area, the formula is length times width. So you're saying what?
So basically, you multiply the length, which is 5, and then the width, which is 6, and that will give you 30.
Okay.
But the shaded part represents 8 out of 30.
Okay. So 8 represents the shaded part. Okay, does everybody agree? Yes. Okay, thank you very much. All right, last group. You had 2 6 times 4/5. Who's your spokesperson? Miss Martin.
So what we did to get 8 times 30 was multiply multiply 2 times 4 and it gave us 8, which was the numerator. And then we multiplied 6 times 5 was 30, which was our denominator. And that's what gave us 8 times 30.
Okay, now how does that expression relate to the model?
So the answer that relates to the model is that it's 30 in all, but the square shaded is 8, so it equals 8 over 30.
Okay, good job. Let's give everybody a round of applause. Okay, all right, now here we go. Your next sheet, turn over. Okay, so on your next sheet, you have 4 different models. Okay, as a group, you should now be able to write an expression. An expression is a problem. Now in our book, it told us to write an equation, okay? Now, the difference between an expression and equation is an equation has an equal sign, an expression does not, okay? So you have 2 columns that is open. You have on the first column, the diagram. So you're looking at each diagram, and first you're going to write an expression, and then on the next part, the shaded area, you're actually writing a fraction to represent the diagram, the shaded area. Okay, any questions? All right, let's go. Let's see what we can do. Everybody should be working as a group. That means I need input from everyone.
Okay, so it's question for 8, so
It's 4 and 5. It's 4 and 5.
oh yeah, the 20.
It's 20.
Yeah, see,
I thought I was 20. I know I was wrong. I just counted.
Okay, so that represents what? The answer that y'all just stated. This is what y'all stated. Okay. So y'all just said this. Okay. So first, everybody should be inputting. Nobody should just be doing the work. Everybody need to be trying to write an expression first and see if everybody writes the same expression. If you guys do not write the same expression, then y'all need to come up with what expression belongs there. Okay? So y'all just said this. Okay? So obviously this is this part. Okay? How can y'all make a expression meaning something like this? This is not the answer, but this is an expression. If I did 1/2 times 2/3, that's an expression. Okay? The book said an equation. Equation has an equal sign. I just want the expression. So, what expression can you create that models this answer that y'all stated? Okay? That's what y'all doing.
Times 3. right here is 2, and
That's it.
Okay.
so basically I got 2 times 3 is going to be the but for the fractions, I got 1/4 and 1/5 because I got 1/4 and 1/5 because first I counted all the numbers, the units, squares, and I got up to 20. And I know 5 times 4 equals 20, and so I got that. And for these right here, I got 2 and 3 because there's 2 rows shaded and there's 3 in each one.
Okay. So you got an expression that says 2 times 3, and I don't know what this is. Does something that go right there?
Oh yeah.
Okay. So if I was to solve this, 1/4 times 1/5, okay? 1 times 1 is 1, and 4 times 5 is 20, okay? But I still gotta multiply 2 times 3, okay? 2 times 3 will give me 6. This will become an improper fraction. Let me do exactly what you got. So 2 times 3 was gonna equal 6. That's a whole number. 1/4 times 1/5 will give me 1/20. I need to turn this into a fraction, whole number. So, does this give me 6/20?
Yes, ma'am.
So could that be an expression for that? All right. Okay. Anybody got anything different? Everybody's expression may not be the same. What you got?
I got 2/4 times 3/5.
2/4 times 3/5. Okay. 2/4 times 3/5. 2 times 3 is 6. And 4 times 5 is 20. Correct. That's all you have to do. If you can prove it, then if you can prove or create an expression to model what is the total number of squares and the total number that's shaded, then that is correct. Good job. Okay, continue on. We working, we just not copying. We working. Have y'all asked each other, do y'all agree? Because he's done number 1. Okay. What is this right here? That's I would check with my group. I think you guys should be checking with each other.
Okay, for B, do y'all agree 4 over 5 times 3 over 4?
What is this right here?
Representing for the
Okay, so none of these are just whole numbers. So the 6 that you have, you should be not just the shaded area, it should be in a fraction form. So they all should not just equal whole number. I want to watch Landis do one and explain it. Do B.
So for B is 12 over 20, but then 4 times 3 is 7, and then 3.
Hold on, wait. So first you said 12 over 20. Okay, so 12 represents what?
The part shaded, and then 20 represents how many are in total.
Okay, so how does your expression represent the model?
Because 4 times 3 is 12.
No, I understand that. 4 times 3 is 12, but where did you get the 3 for the denominator, and how did you get the 4 for the numerator? You have to be able to explain that. Remember, I told you it's not about do I have the answer. It's can you provide a reasoning? How does this 3, which is the denominator, and this 4, which is the numerator, relate to this model? How did you figure that out?
So 4 of the part, so the reason
that I put 4 is all. So there's 4 times 3 equals 12, but every single 4 parts, there are 4 parts shaded for each one.
Say that one more time.
There are 4 parts shaded for each one.
And I gave you 12.
It doesn't say anything about simplifying. It does not say anything about simplifying. But my thing is this. We talked about groups and we talked about rows. We talked about when we had 1/3. Yes, that's what I'm saying. Like you can't. Hold on, let me get a. Yes. How did you know that the numerated? Now we know was shaded, but how did you get 3 as the denominator?
You saying it's 3 going down, but 3 in the 4. So I have 4, so which would be 4 over 5 times the 3 over 4.
And what is this? 4 over 3 is what type of fraction? This is an improper fraction.
Your numerator and your denominator.
Okay. So think about it this way. This is what we've been doing. Okay. How many groups there are? 1, 2, 3, 4. Okay. 5 to be honest with you. Well, we're looking at how many basically have been shaded twice. So these shaded parts represent what's been shaded twice. So 1, 2, 3, 4 is the denominator, and 3, which is what's been shaded, represents the numerator. When we talk about area, we're talking about the length of something times the width. Length times width. Okay? That's how you should be able to explain it, that there are four columns. Okay? And only 3 of those columns have been shaded twice. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 in all. 4 columns, 3 rows have been shaded twice. So the 4 represents the number of columns. The 3 represents the number of rows. Or that represents what's been shaded out of these 3 rows. Okay? What we coming up with?
You finished.
How you gonna change that into out of an improper fraction?
Okay, how did y'all prove this? This is an improper fraction. Improper fraction.
See, I should just skip with my X.
Okay.
This is 2.
Huh?
This is an improper fraction.
I don't know.
It is.
What makes a fraction improper? Okay. Miss Ivy, go tell everybody we will switch at 1:55. I need more minutes.
I think there's 40 parts. I multiplied this by this, and it gave me 40, so that means there's 40 parts in all. So we already know that there's 40 parts. 1, 2, 3, 4, 5, 6, 7, 8.
I love the equations, the equations that you guys are coming up with.
Because as soon as I looked at this one, I knew it was going to be like a whole.
Because all of these are shaded. So how many? There's 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4. Is that 2? My finger keep. That's 5.
This is 5, and this is 5.
Okay. 5 times what? 4. All of it is shaded. So 5 times 4 is what? 20. Okay. So I got 20 squares all together, and all 20 of them are what? Shaded. Okay. So 20 as the numerator, 20 as the denominator. 20 over 20, that's makes what? One whole. Okay? Good
As
job.
soon as I start this one, I know it's gonna start getting even getting even bigger. Cause the way I saw it going from the corner right here.
Okay? All right? Boys and girls, if you guys complete, there is a question number 3 I need you to answer. Number 3, I need you to answer question number 3.
For this one, this is 24. And all of it is 40.
Question number 3.
And this one's 40.
No, we only count the shaded part.
But she said,
In about 1 minute, I need everybody to now go to number 3. I need you to answer the question for number 3.
What pattern did you notice about?
Okay? It say, what patterns do you notice in the table? What patterns?
All right. I know the pattern. All right. So it was A, B, and C.
oh, I'll tell you guys, this is the pattern. Like, you know this is blank. I mean, we know this.
Okay? How did you come up with this?
Okay, so it is for these is 24 shaded, so I knew
Okay.
to put so all these in the group together is 40. So I knew to put 6 over 10 times 4 over 4. I knew 6 times 4, which was 24, which was my numerator. Then I knew 10 times 4 was 40, so my denominator. So I put the two together and it gave me 24 over 40.
Good job. Y'all should be looking at patterns. What patterns do y'all notice?
The patterns was that on how. Okay.
Somebody write a sentence, a complete sentence. Y'all need a complete sentence right there.
Okay, we can see the patterns we know.
Okay. I need everybody to be asking your teammates, what did y'all come up with for what patterns do you notice?
We noticed that.
You need to write you a complete sentence, and somebody's going to tell me what you notice.
So you say the patterns we notice is the length keeps being 4. Wait, it is. Make it 4.
Okay, I'm gonna give y'all 30 seconds. 30 seconds.
How would we say it like that? The patterns we notice is the length being 4. Equals what? The patterns we notice is the
What type of patterns? Everybody should be done wrote a sentence. You have now maybe about 10 seconds. What patterns? Talk amongst your group. What patterns do y'all notice?
Wait, she said.
That's what the sheet said. What patterns? Do you notice a pattern or patterns?
Yes, they all equal.
Okay, well you guys need to, okay, if that's what you guys have, somebody needs to write a sentence.
These very what you got.
Okay? And 10, 9, 8, 7, 6, 5, 4,
Even numbers.
3,
Of the areas.
2, and 1, boys and girls. All pencils are down. Okay? Good job on working in the group. It's my turn now. I have the floor. Good job working in the group. Let's go over some of these. Now I'm going to go over the expressions that you should have gotten. You don't need a pencil. I'm going to call on one person from each group, and you're going to share with me your responses from question number 3. All right? So on A, you should have had an expression, and some of you guys had some very great expressions. When you solved your expression should have got 6/20, okay? This first group over here, Miss Hammond had a great strategy. I'm just going to share. The expression that she came up with was not the simple 2/4 times 3/5. That was the simple version, okay? She gave me 2 times 3 times, in parentheses, 1/4 times 1/5. And that very much is an expression, okay? On B, you should have had 3/4 times 4/5. So if anybody got anything else different, another expression that you wrote, okay? The answer for that was 12/20. We did not reduce these today because it didn't ask us to what? Simplify, okay? The next one on C. C stated all of those blocks are shaded, okay? All of those squares are shaded. So 4/4 times 5/5 is the expression that you could have created to get 20/20, and 20/20 is what? One whole. One whole, okay? The last one, D. D, you have one part shaded and one part that is not, okay? You should have had 4/4 times 6/5, or 6/5 times 4/4 to get 24/20. 24/20 is a what? Improper fraction. It's improper, boys and girls, because the numerator is what? Bigger than the denominator. Okay? All right. So, Team Candice, what patterns did you guys notice?
The patterns that we noticed is that all of the answers are even.
All of the answers are even numbers. Okay. Miss Davis' team.
We noticed that the numbers are going in order like 2, 1, 2, 3, and 4.
The numbers are going in order. What you mean?
Like for the numerators that we saw that it was like 1 and 2 and 3.
And 4. So you're saying that there is some type of connection with the numerators. Okay? Miss Princess Oliver team.
The patterns we notice is the lengths are the same for each question. Like it kept on being 4.
Okay? The lengths kept increasing.
No, the length stayed the same for each question.
The length stayed the same. And what was the length?
4.
4. Okay? Come on, Miss Curry.
So we noticed that for each of the answers all of their denominators are 20.
Okay, all of the denominators are 20, so the total parts was 20 in each one. Okay, so let me share a response with you, boys and girls. One thing that you should have noticed is that the shaded regions looks like it is growing. Okay, first we started out with 3, then we went to what? 12, then we went to 20, and at last we ended up at 24. So the shaded areas increased on each problem. Nobody should be erasing anything. Your pencil should be down. Okay? The next thing is, in the first 3 diagrams, yes, baby.
So for D, I just counted them and it says 24/40, and when you came over here you said it was 40.
I didn't say that. I said that's what you had. I didn't say that was right. But did y'all consult as a team together? Okay, are y'all looking at the fact that there is a line right in here? They're only talking about this portion. Did y'all look at this? They're only talking about this area right here. Yes. Now, okay. So then also in the first 3 diagrams, the shaded regions gets longer and wider by 1 column and 1 row each time. The area is always equivalent to a certain number of 20ths. Okay? So boys and girls, That is our lesson for today. On tomorrow, we are going into multiplying mixed numbers. Okay? Multiplying mixed numbers. Mixed numbers. That means that a mixed number is made with a whole number and a fraction. What type of fraction though? What type of fraction is that? A proper fraction. So to make a mixed number, you have to have a whole number and a proper fraction. Okay? Your homework for tonight, boys and girls. Yes, ma'am.
Can't a mixed number come from an improper fraction?
You can turn a improper fraction into a mixed number, and that's what we'll get in on tomorrow. So tonight for homework, I have 2 videos for you to look at before you attend class tomorrow. You want to make sure that you look at those 2 videos so that you will not be lost. Okay? Any questions? All right, your name should be on your paper. I want all papers in the air now, at the current moment. Okay? Class is over.